Even in the absence of a brain, brittle stars are fully capable of learning. Greetings, everyone. In today's video, we will be delving into the fascinating subject of brittle stars and their remarkable ability to learn without the presence of a brain. As humans, we often associate intelligence with the size of one's brain. However, recent research has unveiled that brittle stars, despite lacking any form of brain, are capable of acquiring knowledge through first-hand experience. Without any delay, let us begin our exploration on this intriguing topic. It is a common belief among humans that intelligence is directly correlated to the size of one's brain. However, recent research has uncovered a fascinating phenomenon in which brainless creatures known as brittle stars are able to acquire knowledge through first-hand experience. Brittle stars, close kin to starfish, primarily occupy their time concealed beneath rocks and crevices within the ocean, or alternatively, they may choose to burrow within the sandy depths. With minimal cerebral presence, these elusive marine organisms possess a network of nerve cords that extend down each of their 5 undulating appendages, converging to create a nerve ring in close proximity to their oral region. Lead author Julia Notar, conducting research for her biology PhD in Professor Sonke Johnson's lab at Duke University, stated that there is an absence of a processing center. Notar explained that the nerve cords possess the ability to function autonomously, operating as individual entities. This can be likened to a committee rather than a single authoritative figure. According to a study published in the journal Behavioral Ecology and Sociobiology, researchers Notar Johnson and former Duke undergraduate Madeline Goh have found that brittle stars are capable of learning through association with just this minimal amount of information. The process of classical conditioning is employed in this form of learning, where various stimuli are linked together. One well-known demonstration of this is the renowned experiments conducted by Pavlov with dogs. These experiments revealed that dogs, after being consistently fed upon the ringing of a bell, would eventually begin to salivate at the mere sound of the bell, even in the absence of any food. This is a common behavior among humans. When the sound of a smartphone notification repeats itself multiple times, it begins to hold a significant significance. The mere sound of someone else's phone emitting the same ping or buzz as yours is sufficient to instinctively reach for your own device, anticipating the arrival of a new text message, email, or Instagram update. While a few studies have shown classical conditioning in starfish, the majority of echinoderms, which encompasses about 7,000 species like brainless starfish, brittle stars, sea urchins, and sea cucumbers, have not undergone testing for this type of conditioning. In order to determine the learning capabilities of brittle stars, a group of researchers conducted an experiment involving 16 black brittle stars, Ophiocoma echinata. Each brittle star was placed in a separate water tank, and their behavior was recorded using a video camera. To train half of the brittle stars, the researchers would dim the lights for a duration of 30 minutes during feeding sessions. Each time the lights were dimmed, a delectable piece of shrimp, a favorite food of the brittle stars, would be placed just beyond their grasp in the tanks. Similarly, the remaining portion of the group received an equal amount of shrimp and underwent a 30-minute period of darkness, although never concurrently, as the creatures were fed in illuminated surroundings. The animals, regardless of the lighting conditions, primarily sought refuge behind the filters in their tanks, emerging solely during mealtime. However, it was only the trained brittle stars that acquired the ability to connect darkness with nourishment. At the onset of the 10-month duration of the experiment, the creatures would conceal themselves upon the extinguishing of the lights. However, as time progressed, the animals established a correlation between darkness and mealtime, prompting them to respond as though nourishment was imminent. They would cautiously emerge from their hiding places whenever the lights were extinguished, even in the absence of any food being introduced into the tanks. The brittle stars had acquired a fresh connection. The extinguishing of lights indicated the imminent arrival of food. Their response did not require the detection of scent or the experience of taste from the shrimp. Simply perceiving the dimming of the lights was sufficient to prompt them to respond and gather for their evening meal. Even after a 13-day hiatus from training, during which the lights were repeatedly dimmed without providing nourishment, the lesson remained ingrained in their memory. The outcomes, according to Notar, are filled with excitement as they provide conclusive evidence of classical conditioning in this particular group of creatures, which has not been previously demonstrated. According to Notar, the fact that brittle stars possess the ability to learn indicates that they are more than mere automated scavengers, comparable to small robotic vacuums tidying the ocean floor. Their capacity for learning suggests that they have the potential to anticipate and evade predators, as well as anticipate the availability of food as they acquire knowledge about their surroundings. Moving forward, Notar's objective is to begin unraveling the mechanisms by which they acquire knowledge and retain it, despite having a nervous system that starkly contrasts with our own. Frequently, individuals inquire about the methods employed, expressing their curiosity by asking, "How do they accomplish such feats?" Notar responded. "At present, we remain uncertain. However, I am optimistic that within the next few years, we will acquire a greater understanding and be able to provide more comprehensive explanations." The funding for this project was provided by the US Department of Defense, specifically through the National Defense Science and Engineering Graduate Fellowship Program. Additionally, support was received from the Rachel Carson Scholars Program at the Duke Nicholas School and the Duke Biology Department. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.